Okay, so welcome to our course R24 Manufacturing Processes. So today we are going to discuss metal joining process. So as we know, manufacturing means raw material converted as the finished products. So there are plenty of manufacturing methods we have. For example, casting, forging, metal machining, right? So additive manufacturing. These are some of the manufacturing process. Those methods we apply some pressure. If it is a forging, we just give the heat to the workpiece material and we apply the force and we will get the final shape. If it is a casting, we will pour the molten metal into the cavity and then we allow to solidify. We will get the component. Similarly, machining, we place a workpiece in a machine tool like lathe or drilling, and the cutting tool will remove the unwanted metal from the workpiece. Additive manufacturing is a 3D printing. It is a layer by layer manufacturing. So layer is deposited over previous layer and we will get the final shape. So these are the manufacturing process. So another one manufacturing types of manufacturing is metal joining process. Where here we are not add any metal, right? So we just join two metals, but we add the metal. Then we say it's a filler metal, right? So gap fill. So right, so the metal is added to fill the gap between two metals, right? So metal joining process, we have a plenty of types. One of the examples are welding. So welding is metal joining process. Another one is soldering, bracing. So there are so many types, so many joints we have, right? So this is what permanent joint. Similarly, we have a temporary joints we have. So for example, bolt nut. These are the temporary joints, bolt nut. So that the term temporary means you can unbolt, you can unscrew your bolt and you can dismantle. So disassemble your component, right? It is a temporary joint, but here we say it's a permanent joint because if you want to remove or if you want to disassemble, you need to destroy the welding. Otherwise, you cannot segregate. Right, so today we are going to discuss with the metal joining process. So these are the content we have. So before begin, we must know what is meant by welding. Right, so welding is a material joining process which produces collisions of material by heating them to suitable temperature with or without the application of pressure or by the application of pressure alone and with or without use of filler metal. Right, so welding generally it is a metal joining process. So we have a two material. The two metals are joined with the help of welding. So welding is a material joining process which produces collisions of material. So collisions in the sense, if you heat one particular material, it will goes plastic state. Right, so that molten state. So if you join at molten state, the entire surface will join. So which produces collisions of material by heating them to suitable temperature. So based on our raw material melting point, we will add the heat. So by heating them the suitable temperature without application of pressure. So sometimes we joined. If we add the heat to the workpiece material and we allow to solidify, automatically it will join. But sometimes we add the heat to the workpiece material and we give the pressure to join. Right? So there are with or without application of pressure or force, right? Or by the application of pressure alone, right? And with or without use of filler material. So filler material is a material which is used to fill the two metal gap. The gap between two metals, right? So if you join two metals, it may have some gap. So that gap need to fill with the help of filler material, right? So with or without the use of filler material. This is a definition of welding. So welding is a material joining process which produces collisions of materials by heating them to suitable temperature with or without the application of pressure or by the application of pressure alone and with or without the use of filler material. Right, so it is used for making a permanent joint, right? As I said earlier, it is generally welding is a permanent joint. Why we say permanent means if you want to disassemble or if you want to segregate two parts after welding, you need to destroy the welding. You cannot get as it is before joining. So you need to destroy the welding, right? So this is what permanent joint. Instead of permanent joint, if you use bolt nut, you can unscrew. Right, so you can disassemble very quickly. right? So this is what permanent joint. It is used in many applications such as automobile bodies, aircraft frames, railway wagons, machine frames, structural works, tanks, furniture, boilers, general repair work, and shipbuilding. So there are many applications we can use as a welding. So welding can be used in many applications. Right, so the next term is weldability. Right, so ability. So what is meant by ability? In the sense able to. For example, the person ability, eating ability is eating ability in the sense the person X can eat 5 idlis. Right, so it is like capable. He capable to eat 5 idli. Similarly, if the person eats, the another person can eat may eat more than 10 idlis. It is the capability of that person. So the capability is varied with the persons. Similarly, weldability in the sense we can split as a term weld plus ability. So the metal, in easy manner we can weld. That is called weldability. The weldability of metal is usually defined as its capacity to be welded into a specific structure. Right, so capacity to be welded into a specific structure that has certain properties and characteristics and will satisfactorily meet service requirements. So this is what weldability. So you can split the term weld plus ability. So capacity to be welded, we say it's a weldability. Right, so we can weld, but our required specific structure can be welded. Right, so and it needs to meet a service requirement. This is what weldability. Right, so the factors, right, which affects the weldability, there are 3 factors. One is a metallurgical capacity, mechanical soundness, serviceability. So we have 3 factors to describe weldability: metallurgical capacity, mechanical soundness, serviceability. Okay, so metallurgical capacity, metallurgical in the sense material, microstructure level. So the parent metal will join with the weld metal without formation of deleterious constitutional alloys. Right, so this is what metallurgical capacity. So the parent metal is those metal who we are going to join. Right, so the parent metal will join with the weld metals without formation of deleterious constitutional alloys. So mechanical soundness is the joint after making a welding, the joint will be free from discontinuities, gas, porosity, shrinkage, slack or cracks. So if you got good welding, then we say it's a mechanical soundness. So the mechanical soundness should be more if it is a good weldability. Serviceability, again welding needs to meet the service requirement. So serviceability, weld is able to perform under varying conditions or service. Right, so for example, the joint need to withstand at extreme temperatures, corrosive environment, fatigue and high pressures. Right, so if you increase the temperature, the weld cannot be segregated. Right, so this is what serviceability. Right, so types of welding. So we have 2 more types. Generally we have mainly we have 2 more types. One is a plastic welding or pressure welding. The second one is fusion welding or non-pressure welding. So plastic fusion. Okay, so the plastic in the sense, for example, if you have a plastic chair, right? So you have a plastic chair. If you keep on increasing the temperature of plastic chair, right? Assume that you have a plastic chair and you keep on increasing the temperature of plastic chair, then the shape of the plastic chair will change. Right, so without adding any pressure, any force, it will change. This is what a plastic. So the plastic welding, the name implies that the piece of metal to be joined or heated to a plastic state and forced together by external pressure. Right, so so the plastic chairs, so it will change the shape, but if you want to change a different shape, then you apply the pressure. Right, so if you apply the external pressure, then we say it's a plastic welding or pressure welding. So you apply the pressure, then we say pressure welding. So similarly, if you the plastic chairs, you keep on increasing the temperature, but you didn't apply any force, but the shape will change, then we say it's a fusion welding, because you didn't apply any pressure on over the plastic chair. The material at the joint is heated to a molten state and allowed to solidify. Right, the examples of plastic weldings are resistance welding. Right, so resistance welding. The examples for fusion welding, we say it's a gas welding or arc welding. Right, so the principle is simple. So if you want to join 2 metals, you need to increase the temperature of those metal. If you joined with the help of pressure or force, then we say it's a pressure welding or blast welding. If you didn't apply any force, you let allow to solidify, right? So if after solidification, so after cooling, it will join automatically, then we say it's a fusion welding or non-pressure welding, right? So this is the main two types of welding. Again, we have a 7 more classification. One is a gas welding, arc welding, resistance welding, thermite welding, solid shell welding, newer welding, and related process. So these are the 7 topics, right? So we have a main 7 classification. So as the name implies that gas welding means that metal joining is done with the help of gas, then we say it's a gas welding. Metal joining is done with the electric arc, then we say it's a arc welding. Metal is joined with the help of electric with the resistance, right? So if you apply the force, then we say it's a resistance welding. So or similarly, if the metals are joined with the help of thermite mixers, then we say it's a thermite welding. So solid shell welding, it's one of the process which can be some examples are few friction welding. These are some of the weldings, solid shell welding. Similarly, newer welding, it may be the laser beam welding or electron beam welding, and related process means it may be the soldering, brazing. So those are the classifications of welding process. So if you further classify the 7 topics, so one is a gas welding, we have a 3 more type: Oxy-acetylene, Air-acetylene, Oxy-hydrogen. If it is arc welding, we have a carbon, metal inert, gas tungsten, atomic hydrogen, plasma, submerged, electro gas, and then electroslag. These are the category of arc welding. Similarly, if you consider resistance welding, then we have 5 more topics. One is a butt, spot, steam, projection, percussion. Similarly, we have a thermite, solid state welding, we have friction, ultrasonic, diffusion, explosive, forge welding. These are some of the examples for solid state welding. So newer welding, it may be the electron beam or laser beam. Other process like brazing, soldering, oxy-acetylene cutting, arc cutting, hot facing, bronze or braze welding. These are the other related process, right? So these are the classification of welding process. Now we are going to discuss only gas welding, right? So gas welding and its types. Okay, right. So we start with gas welding. So the gas welding is a welding process that melts and joins metal by heating them with a flame caused by the reaction between oxygen and fuel gas such as acetylene and hydrogen, etc. So gas welding, we know that welding is done with the help of increasing the temperature, right? So if you want to increase the temperature, you need to create a flame, right? So you need to create a flame. The flames are created with the help of gas, then we say it's a gas welding. The gas, in the sense the oxygen is the one which is responsible to generate and spread the flame, right? So oxygen is the more dangerous element. You know that. So the gas welding is a welding process that melts and joins metal by the heating them, right? So we are going to heat the workpiece material with a flame. The flame is caused by the reaction between oxygen and fuel gas like acetylene, hydrogen, all those things, right? So we are going to mix oxygen with air or acetylene or hydrogen. So the combination, the mix of these two gases will create the flame. That flame is used to increase the temperature of workpiece material. That is what gas welding. So the process is fusion welding process, wherein joint is completely melted to obtain the fusions, right? So we will raise the temperature at the above melting point, so both the materials attain fusion state, right? This is also called as oxy-fuel gas welding. So there are 3 classifications, as I said: oxygen, acetylene welding. So oxygen plus acetylene, we say oxy-hydrogen welding. Air and acetylene, right? So air has oxygen, right? So atmospheric air. So if you mix atmospheric air with acetylene, then we say it's a air-acetylene welding. If you mix oxygen and hydrogen, then we say it's a oxygen-hydrogen welding. So gas welding, we have 3 more types: oxygen acetylene welding, air acetylene welding, oxygen hydrogen welding. So we are going to see these 3, right? So the sound weld, the good weld, is obtained by selection of proper size of flame, right? So the flame size, it should be optimized. So selecting proper size of flame and amount of flux used. We are going to see what is meant by flux and what's the need for that, right? So we will see amount of flux used, filler material, and method of moving a torch. So filler metal and method of moving torch. The temperature generated during the process is 3300 degrees Celsius. Approximately, just imagine the temperature is 3300 degrees Celsius, right? So we cannot touch, right? So the temperature ended during the process is 3300 degrees Celsius. So this is what gas welding, this good weld in good weld can be obtained with the help of gas welding. We need to maintain this fight, right? So we will see what is maybe flux, right? The flux, it is one component which is used in welding process when the metal is fused, or if you raise the temperature of workpiece material, the oxygen from the atmosphere and the torch combines the molten metal and forms the oxidized results defective weld, right? So after welding, the joints are in more temperature, so it will make a reaction with the atmosphere. So atmosphere we have oxygen, so it will form the oxides, right? So after welding, the welding surface can interact with the atmospheric, and atmospheric air contains the oxygen and it will make the oxidize. This oxidize is a very dangerous one. It will create the porosity and it will create the defective weld. So in order to avoid this, we use flux, right? So the gas welding, the sound weld is obtained by there are 5 reasons. One is selecting the proper size of flame, amount of flux used, filler material, and method of moving torch, right? So this is what generally, right? So sound weld means if you want to get good weld, right? Good mechanical weld, you need to select a proper flame size and amount of flux, filler material, and melting the method of moving torch. The temperature around 3300 Celsius, right? So this is what sound weld. The flux is one of the important material which is used in welding. The main purpose of welding is to prevent oxidation. So when the metal is fused, oxygen from the atmosphere and the torch combines with the molten metal and forms oxides, results in defective weld. So which means if you want to weld the two metals, you need to raise the temperature of the workpiece material. So and then you will allow to solidify, right? So if after making a weld, the joint surface are in more temperature, so it will interact with the atmosphere. Atmosphere has the oxygen content, so it will make oxidize. So this will causes the poor welding and defective weld. So in order to avoid oxidation, to prevent oxidation, we use fluxes. So the fluxes are added to the weld metal to remove oxides. So the common fluxes used are made up of sodium, potassium, lithium, and borax. The flux can be applied as a paste, liquid, powder, or solid coating or gas. It may be any form, right? So this is what a flux. So first we are going to see the oxy-acetylene welding. So generally we say OAW, oxy-acetylene welding. So the fusion welding performed by a high temperature flame from combustion of acetylene and oxygen, then we say oxy-acetylene welding. So as we know, the joining are done by temperature riser. So the temperatures can rise with the help of flame. The flame is generated with the help of two mixture of gases. The two gases are oxygen, acetylene, then we say oxy-acetylene welding. So the flame is directed by a welding torch. Filler metal is sometimes added. So filler metal we added sometimes, but the filler metal should be the same as the base metal or parent metal. So composition must be similar to base metal. The filler metal it adds the extra metal to the welding. The filler rod often coated with a flux, so to clean surface and to prevent oxidation. So this is the image of gas oxy-acetylene welding. So from bottom we have a base metal, and we have two metals over there. So we will make the joint with the in between these two. So we have a nozzle. So the nozzle we send the air, 2 airs, the mixture of C2H2 for acetylene and O2 for oxygen. So both the mixers increase the temperature and it will create the flame. The flame is passed to the joints. So in order to add the material, we use filler rod. This is what oxy-acetylene welding. So how it works, right? So most popular fuel among OFW group because it is capable of higher temperature than any other, up to 3480 degrees Celsius. So if we compare gas welding, this is one of the most common method, oxy-acetylene welding, because it has advantages like it will create a temperature up to 3400 degrees Celsius. In terms of Fahrenheit, it is a 6300 degree Fahrenheit. Right, so the reaction, how it temperature takes place. So the heats are produced in two stages. One is a first stage reaction, inner cone of flame, right? So the inner cone of flame. So C2H2 stands for acetylene plus O2 stands for oxygen. So C2 acetylene plus oxygens are combined or mixed. It will make 2CO. CO stands for carbon monoxide. So it will make a carbon monoxide and hydrogen plus heat. So here one type of heat is produced. The second stage, again the carbon monoxide with hydrogen and oxygen are combined, and it will form the carbon dioxide. So it's a black color, right? So carbon dioxide with the water and heat. So the heats heats are produced with two stages, right? So based on the flame, we have a three more type. One is a neutral flame, oxidizing flame, carburizing flame. We have a three more flames, right? So one is a neutral flame. So neutral flame means we know that the mixing of two gases, acetylene and oxygen, both are in same composition, same percentage, 1:1 ratio. Both are same ratio, then we say neutral flame. So for example, addition of little more oxygen gives a bright whitish gold surrounded by the temperature transparent blue envelope is called neutral flame, right? So generally it is 1:1 ratio. So this is what a neutral flame, right? So the inner cone and then outer cone. So inner cone temperature may be the 3040 to 3000 degrees Celsius approximately. Outer envelope, it may be the 3800 degrees Celsius, right? So this is what a neutral flame. The ratio generally is 1:1, right? Oxygen and acetylene both are mixed at a equal proportion. It affects no chemical change in the molten metal and therefore will not be oxidizing or carburizing the metal. So we will mix the air and acetylene in equal proportion, so it won't it won't change any chemical properties. So it affects no chemical changes. So there won't be oxidizing and carburizing the metal. The neutral flames are used for welding steels, aluminium, copper and cast irons. Right, the second flame is oxidizing flame. Compared to this flame, this is what some thick flame. Here we have a thin flame, right? So oxidizing, so the mixture is oxygen acetylene, the oxygen content is more. So 1.5:1. So oxygen content is more compared to acetylene content. If more oxygen is added, then gold becomes a darker and more pointed, while the envelope becomes shorter and more fierce. Is called oxidizing flame. So oxidizing flame means oxygen content is more, so O2, C2H2. O2 stands for oxygen. Has the highest temperature about 3400 degrees Celsius. So this is the temperature may be 3400 degrees Celsius. Oxidizing flame is of limited use in welding. It is not used in welding of steel, used for welding, braze and brazing operations. So this is for oxidizing flame. So oxidizing flame means we will add more oxygens compared to acetylene, right? So ratio is 1.5:1. The third is a carburizing flame. This is opposite to oxidizing. So we will add more acetylene, right? So oxygen is turned on, flame immediately changes into the long white inner area surrounded by the transparent blue envelope. Is called carburizing flame. Right, so carburizing flame, so we have we can get three kind of cones, right? The one is a bright inner cone and luminous cone, reducing carburizing cone, and then is a blue envelope. So this is what carburizing flame. So the variation between these two gases, we will create three types of flame with the three different temperatures, right? So the equipments are this is a general equipments. Axial welding as a general equipments. We have a cylinders for store the oxygen as well as acetylene. So generally oxygen cylinders are it may be in red color, acetylene it may be the black or green color. So gas cylinders, we have a pressure. Oxygen is stored at 154 kgf per centimeter square. Acetylene has a low pressure with the high low, it may be the 0.07. If it is high, then 1 kgf per centimeter square. So the cylinders are used to store the oxygen as well as acetylene. So the top of cylinder we have a regulator. So the regulator is nothing but our valve. It will regulate the flow, right? So we can adjust the flow pressure regulators to reduce the cylinder pressure to the required working pressure. So we stored gases at high pressure or low pressure, but our application requires some controlled pressure. So if you achieve that, if you want to control the pressure, you need to regulate the valve, right? So pressure gauges to check the air pressure. So we have a pressure gauges, the circular, we have a pressure gauges. So it is used to check whether how much pressure the fluid flows, right? So pressure gauge to check the air pressure. Welding torch, it is a tool for mixing oxygen and hydrogen. So this is a welding torch. So the two gases are comes in different hoses and it mixed here. The welding torch is the mixing zone. So gas as well as acetylene is mixed here. Welding torch. Welding tip, it's a diameter of tip opening depends on the type of metal to be welded and its thickness. So welding tip, it is a diameter of welding tip, it depends on the joining the material as well as. So if the gases are mixed, it will create the flame. The flame is exit with the help of welding tip, right? So check valve and non-tittle valve, it is a one type of valve. It will act as a one way, right? It won't allow the back pressure. So check valve or non-tittle valve we use. And hose is a pipe. It acts as a passage to flow air or acetylene. And we use some goggles, gloves or spark lighter for our safety purpose. Goggles means it's a goggles, so safety goggles. In addition to the above, welding rods or flexors can be used, depends on our applications, right? So this is what oxy-acetylene welding. Now we are going to see air-acetylene welding. So the principle is same. We are going to mix the two air. The previous we mixed acetylene with oxygen. So here we mixed with air with acetylene, but air has a oxygen content. So this process used for torch similar to Bunsen burner. The operates on a Bunsen burner principle. So Bunsen it is a mixture, right? So it will extract the oxygen from atmospheric air. So the air is drawn into the torch required and mixed with the fuel flame. The gas is then ejected and ignited, producing an air fuel flame. The common fuels used are acetylene, natural gas, propane and butane. So this type of welding has limited use since the temperature is lower than the attained by other gas process. So atmospheric air has not only has air, it has also other gases. So the temperature is somewhat minimum. The air fuel welding process are used in lead welding and many low melting temperature metals and alloy like in brazing and soldering process, right? This is what a air-acetylene welding. The next process is oxy-hydrogen welding. So the oxy-hydrogen process were once used extensively to weld low temperature metals like aluminum, lead and magnesium. But it is not popular today because more versatile faster welding processes such as TIG and MIG have replaced the oxygen-hydrogen flame. Right, so oxygen-hydrogen flame can be used for low temperature metals, but it is a construction wise it is a very difficult one. So nowadays the growth of TIG and MIG welding it surpassed the oxygen gas welding, hydrogen welding. The process is similar to oxygen-acetylene welding with the only difference being special regulator used in the metering and the hydrogen gas. So hydrogen gas, in order to control hydrogen gas we use some special regulator over there, right? So thank you.